Are they here? If science fiction and Hollywood blockbusters have taught us anything, it's that most of us will find the impending alien invasion to be loud, violent, and unpleasant. Our new intergalactic overlords will rob our planet of its resources and show no sympathy for us. In 2017, a mysterious object known as Oumuamua captured the attention of both scientists and the general public. It was rushing away from the sun in a way that astronomers could not explain, confusing experts and prompting some to assume that it was an alien spaceship. Now this mysterious Oumuamua is back at our doorstep and sending signals. With the prospect of alien life or even an attack, could Oumuamua be a reconnaissance vessel sent here by aliens, or could there be more to it? Join us as we explore how Oumuamua suddenly showed up again and is sending signals to Earth. As a solitary star, our sun dangles precariously at the galactic core. There are about 400 billion stars in our galaxy, all functioning similarly, and there may be as many as 6 billion planets identical to Earth orbiting these stars. When you factor in the possibility of 2 trillion other galaxies in the cosmos, you find yourself dealing with figures so enormous they could make a mathematician weep. There must be some life on one of the billions of habitable planets orbiting the Sun, and even if it were feasible, could these hypothetical creatures wipe out all life on Earth? The failure to find extraterrestrial life perplexed Enrico Fermi, a nuclear physicist and Nobel laureate. He came up with the Fermi paradox to explain this seeming paradox. Although there was no proof of alien life, the chances of its existence were great. Some have proposed explanations for the dilemma, such as the possibility that extraterrestrial life isn't technologically developed enough to contact Earth just yet, while others have proposed that aliens simply do not want to communicate with humans. Astronomer Frank Drake developed an equation in 1961 to determine the approximate number of extraterrestrial civilizations that are in radio contact with Earth. Our chances of being the sole intelligent species in the Milky Way range from 53.1 to 99.6% according to the most recent calculations, utilizing a variant of the Drake equation to make a more precise calculation. There are simply too many unknowns. Basically, it's possible that we're not alone in the universe, or that there is intelligent life elsewhere. Some astrophysicists believe alien life of some kind could be right on our doorstep. On October 19, 2017, observers on Maui observed an object that seemed to be either an asteroid or a comet. Oumuamua, meaning a messenger from afar, arriving first in Hawaiian, was the first interstellar object other than dust grains ever observed in our solar system. Its fast speed and slanted orbit led scientists to conclude that it originated from beyond our solar system. The exact location of Oumuamua's stellar system remains a mystery. A million years ago, Oumuamua came closest to the red dwarf star 55 Cancri. But in 2018, astronomers traced it back along its original journey to the Sun and discovered that it passed near 4 stars. Oumuamua may have originated there, or it may have been roving across space for even longer. The solar system's planetary bodies, asteroids, and comets all follow tight orbits around the Sun. In contrast, Oumuamua's trajectory was hyperbolic, meaning that the object was rushing toward the Sun at such a high speed that its course could only be minimally bent by the Sun's gravity rather than being captured in a looping circle. Because of this, Oumuamua, which was moving at a relative speed of 163,600 meters per second to the Sun, could simply continue on its way to the solar system's departure. Astronomers were able to trace Oumuamua's orbit as more and more telescopes pointed at it, and they found that it had completed 1 full orbit around the Sun and was now leaving the solar system. It was believed that Oumuamua was very elongated and falling on its end due to its irregular and unpredictable brightness changes. Additionally, astronomers detected a small deceleration from the Sun, which is more pronounced for comets than asteroids. To astronomers, it was all quite unusual. From the solar system's outer regions, comets, which are essentially dirty snowballs, approach the Sun at regular intervals. When heated by the Sun, comets release molecules of water and other substances, creating a luminous halo and, in many cases, gas and dust tails. The comet receives a small push from the ejected gases, which causes it to deviate slightly from the elliptical orbits normally observed around objects like planets and asteroids. Astronomers speculated wildly about the composition and the force propelling Oumuamua outward after its discovery. Despite the fact that it lacked a tail, was too tiny, and was too far from the Sun to absorb enough energy to eject a significant amount of water, plus Oumuamua stands out in more ways than one. Its shape is just one of them. Oumuamua has been seen to be exceedingly long and narrow, with a length of about 1,300 feet and a width of about 130 feet. This needle-like shape is unique among celestial objects. The exact size and shape of Oumuamua remain a mystery due to technical limitations. Astronomers are relying on brightness measurements to make size estimations of the visitor. When the gravitational waves of roving gas giants wrenched Oumuamua out of her orbit, we knew it was an object launched from a spacecraft beyond our solar system. Was it a hydrogen iceberg, a large fluffy snowflake pushed by light pressure from the sun, a light sail, or a spaceship created by an alien civilization? According to a paper in September 2020, there was another object discovered by the same telescope that was given the astronomical name 2020 SO, and it also exhibited a push by reflecting sunlight and no cometary tail around it. As it happens, this celestial body originated on our planet, ejected into orbit in 1966 as part of the Lunar Lander Surveyor 2 mission. This rocket booster featured extremely thin walls. Because of this, it was propelled by reflecting sunlight and had a large surface area relative to its weight. So we know that we produced this object ourselves, we just don't know who produced Oumuamua. Many astronomers have commented since the first observations that Oumuamua seems strange, primarily due to the lack of data we have regarding the object. Because of how fast it passed the photos we have are poor quality, and it is now over 2 billion miles distant out of our line of sight. There are numerous conflicting hypotheses and ideas of what Oumuamua could be despite the limited data that is available. This, according to Loeb, is as likely as any other, and we need to deal with it. So we have one theory that suggests it might be man-made, but there are three others that point to a natural source, and all three of them involve an entirely new kind of object. One of them was a hydrogen iceberg, which is essentially a frozen block of hydrogen that mimics the behavior of a comet, albeit the comet's tail is invisible to the naked eye due to hydrogen's translucent nature. The issue with that is that a piece of frozen hydrogen wouldn't last the trip because it would melt so rapidly. A possibility was raised, perhaps it's a dust bunny, a clump of dust particles held together in a similar fashion to the ones you might find in your own home. For the sunlight to reflect and cause it to move in the direction we observed, its density must be approximately 100 times lower than that of air. The catch is that it will lose all structural integrity due to the hundreds of degrees of heat it will experience as it approaches the sun, much like Oumuamua did. The third suggestion was maybe it was a fragment shrapnel from an object that was disrupted by passing close to a star. On top of that, unlike Oumuamua, which had a pancake shape, the tidal forces for surface stars tend to produce objects with an extended shape. Therefore, there are significant problems with each of the three hypotheses that have been proposed in the scientific literature. He asserts that his theory merits equal or greater seriousness due to the enormous consequences, but also the most likely situation. If you view it as a technological relic, it's billions of years old, because most of the stars were born billions of years before the sun, and so if they had a technological civilization like ours, they already sent out their Voyager 1, Voyager 2 New Horizons missions, and a billion years later these probes are not functional anymore. So they are just like plastic bottles on a beach that are punctured, they suffer damage, they are not really working, but they are out there and they keep accumulating. We can learn about other civilizations by doing space archaeology. This method is drastically different from searching for radio signals, as the latter is analogous to phone conversations in which the other party must be alive. However, therefore you have a relatively small chance of coexisting when they are around, so establishing contact with them is probably out of the question. But if you're applying the principles of space archaeology, that's irrelevant, since what matters is finding the artifacts they left behind. Obviously they would show that civilizations perished. Nevertheless, we might attempt to understand their demise in order to possibly prevent a like destiny. Therefore it could serve as a historical lesson, teaching us to be humble and better prepared for what is ahead. Another possibility is that we can bring even more advanced technologies to Earth if we discover them. Landing on an alien object, reading its label that reads "Made on Planet X" would not only tell us where it came from, but would also provide us a chance to bring that technology back to Earth. It would take us a long time to create the same technology, therefore this might be a method to skip ahead in time. Indeed, it was Oumuamua who sounded the alarm. Could they be closer than we perceive? Not to worry, but in 2013 strange signals were detected by NASA's Kepler satellite telescope, and all of a sudden the idea of a Dyson sphere in our galaxy seemed like a remote possibility. Planets that circle stars outside of our solar system known as exoplanets have been the focus of the telescope's search of the Milky Way. When these exoplanets whiz past a star, it seems like the star gets a little dimmer because they are partially blocking it. In most cases, this dimming is consistent and easy to foresee. However, something really atypical, not shaped like a planet, was moving in front of the star, and Kepler noticed this. Does our neighborhood have a Dyson sphere? The idea of a Dyson sphere put out by scientist Freeman Dyson deals with the possibility that sophisticated societies could tap into the tremendous power of their stars. In theory, a Dyson sphere, a huge shell surrounding a star, could absorb all of its energy. However, in practice, the idea of a Dyson swarm of such devices in orbit has proven to be more realistic. The hunt for extraterrestrial life has focused on these megastructures, possibly recognizable by their infrared emissions. For more than 60 years, they are considered a characteristic of technologically advanced civilizations and an important target in this continuing effort. Envision yourself as the leader of a technologically advanced society. What would you do? The hunt for extraterrestrial intelligence hinges on this seemingly innocuous inquiry, which one would ask in a college bar after a few too many drinks. It might be helpful to have a general idea of what you could be searching for if you are trying to find technologically advanced alien civilizations. This is a question that physicist Freeman Dyson posed in the early 1960s, when the idea of intelligent extraterrestrial life was just beginning to be seriously considered. He wanted to know how a highly developed society would collect energy. We don't know much about extraterrestrial politics or culture, but any technologically capable society would need energy, and probably a lot of it. All of the light from the star could be collected in this way, at least in theory. A Dyson sphere's utility goes beyond only collecting energy. Some portion of a civilization's Dyson sphere, which has a surface area of more than 1 billion Earths, could be used as residential space as well. Despite the boldness of his proposal, Dyson mapped out the fundamentals for constructing such a massive apparatus. Other scientists have spent years trying to figure out how to construct and run this prototypical extraterrestrial megastructure. To create a shell that is 1 mile thick and has a radius equal to Earth's orbit, they discovered that the mass of every planet in the solar system would have to be blended together. The parts of the Dyson sphere would need to be made from all that material, which would require processing the resources necessary to do the task. Would you construct a Dyson sphere if you were in charge of a highly advanced technological society? For over 60 years, Dyson spheres or swarms have been an integral part of SETI, so if you answered yes, you're not alone. They seem likely and maybe even universal, but is that true? There's no way to know except to go looking for them. Whatever the case may be, conventional chemical rockets will never be able to keep up with Oumuamua as it cruises toward the outer solar system. That being said, it is not impossible that we may get a close look at the object. We could send a mission to Oumuamua in the future. According to Lub, if we can figure out how to use lasers to propel small robotic probes with sails to extremely high speeds, launching such a vessel in the next few decades is the goal of projects like Breakthrough Starshot. No matter how successful our pursuit of Oumuamua is, we should learn from its visit and be prepared to launch a full-scale observational blitz the next time an object of this kind passes through our area.